In our previous video, we solved for the LCM of two numbers. Now make sure you watch that video. Today, we will get the LCM of three numbers. Okay, so here are the examples. So the first one is find the LCM of 5, 8, and 10. And for letter B, find the LCM of 48, 72, and 100. Okay, so let's start first with our first problem. So we have find the LCM of 5, 8, and 10. Okay, now if we try to do the skip counting method, it's easy because these are just small numbers. Okay, so for 5, so we can have 5, 10, 15, 20, 25, 30, 35, 40, and 45, and so on. Okay? For 8, we have 8, 16, 24, 32, 40, 48, 56, and so on. Then for 10, we have 10, 20, 30, 40, 50, and so on. Okay? Now, based on this one, based on skip counting, we can see that the LCM now is equal to this. Because this number is the common multiple of this one, okay? Based on skip counting. So, the LCM is 40, okay? But how can we get the LCM of 5, 8, and 10 using the prime factors, okay? But before that, make sure to watch my video regarding prime factorization, which I will link in the description box below. Okay, so how are we going to do that? Okay, so first let's get the prime factors of 5, 8, and 10. For 5, this is already a prime factor. Okay, for 8, we have 2 times 4. Then we have 2 times 2. So this is the prime factor. Then for 10, we have 2 times 5. Now 2 and 5 are already prime factors. Okay? Now what are we going to do next is we're going to, now instead of writing down the prime factors, what we're going to do is we're going to make a prime factor table. Okay, so what we're going to do is we're going to write the factors. Okay, so we have 2 and we have 5. Okay, so what we're going to do is we're going to write here 2 and 5. Okay, again, these 2 and 5 are the prime factors that you see in 5, 8, and 10. Okay? Then what are we going to do next is we're going to, so we have now 5, 8, and 10. Okay? Now what we're going to do is we're going to count how many times this prime factor appear in this number. Okay, so for example, for 2, it doesn't appear in 5. So this is 0. Then for 8, it appears 3 times. So 1, 2, 3. So we're going to write here 3. And for 10, it appears once. So we're going to write here 1. Okay? Now on the last column, we're going to write the maximum number of times that this number appears here. Okay, so in this case, it appears 3 times. Okay, that's the maximum. Then for 5, it appears once here, then none at 8, and once also at 10. So the maximum number of times 5 appear in this 3 number is 1. Okay? So meaning the LCM now is equal to, so in this case the maximum is 3. So you will have 2 times 2 times 2, because the maximum number for 2 is 3, or it appears thrice on the given numbers. Okay, then for 5 it's only 1, so times 5. So if we write this in exponent or in exponential form, we have 2 raised to 3. Now this one is this one, then times 5 raised to 1, or this one to this one. Okay? Now I'm going to link the discussion for exponents and roots and the power of exponents in the description box below. Okay? So here the answer is 40. Okay? Now here we have 2 raised to 3 is 8, times 5 is 40. So the LCM now for 5, 8, and 10 is 40. Okay? Now let's go to our next example. So in this example, we have 48, 72, and 100. Okay? But in this case, it's hard to do the skip counting method because the numbers are too large. So what we're going to do is we're going to get the prime factors of this number. So let's start first with 48. So we have 2 times 24. Then we have 2 times 12. Then we have 3 times 4. Then we have 2 times 2. Okay, so the prime factors now are 2, 2, 2, and 3. Okay, for 72, so we have now 2 times 36. Then we have 2 times 18, then we have 2 times 9, then we have 3 times 3. So these are the prime factors. Then for 100, we have 4 times 25. For 2, we have 2 times 2. Then for 5, we have 5 times 5. Okay? Now what is the next step? We're going to construct our table. Okay? So what are the numbers that frequently seen in the given prime factors? So we have 2, 3, and 5. So we're going to construct tables for 2, 3, and 5. Then so we have 3 numbers again. So we have 48, 72, and 100. Then we have the maximum number of times. Okay, now let's check. Okay, for number 2, it appears how many times in 48? it appears 1, 2, 3, 4. So we write here 4. Then for 72, it appears 3 times 1, 2, 3. Then for 100, it appears twice. So the maximum number is 4. Okay? Then for 3, it appears once in 48. For 72, twice. Then for 100, twice also. So here we're going to write twice or 2. Then for 5, it's 0 in 48. It's also 0 in 72, but it is twice in 100. So we're going to write here 2. So it's 2. Okay? Now we'll try to check out our table. So the LCM now is equal to, so for 2 it appears 4 times, or it appears 4 times. So we're going to write here 2 times 2 times 2 times 2. So 4 times. Then for 3, twice. So we have 3 times 3. Then for 5, it also appears twice. Okay? Now this is also equal to 2 raised to 4 times 3 raised to 2 times 5 raised to 2. Okay? Now 2 raised to 4, or 2 times 2 times 2 times 2 is equal to 16. Then 3 raised to 2, or 3 times 3 is 9. Then 5 raised to 2, or 5 times 5 is 25. Okay? Now, if we multiply this number together, so we have 16 times 9 times 25, it is equal to 3,600. So the LCM now for 48, 72, and 100 is 3,600. Okay? So make sure you revise or practice prime factorization. Then you can solve now for LCM. Okay? Now don't forget to like, share, and subscribe to our YouTube channel, Patrick School from Home. For any questions or topic that you want to learn, just leave a message in the comment section or in our Facebook page or email address. See you in our next lesson. Bye!